Hello, good morning, good afternoon, and happy New Year to everyone, because I guess this is the season for that. So let's wish to everyone a very good 2021 year, at least better than 2020, and hope we'll get some freedom back and stay healthy. With that, I'll start directly. I'll share my screen. If it does not pop up, please tell me. I have some slide to start, but very limited. You know the purpose of this workshop. It's really a demo-led kind of session where we do go into a command line and code and this kind of thing. So I will really focus on that. But before we start, I just would like to get some basic understanding for everyone. And obviously, there is some things I need to clarify, just to be sure we are all aware of what we are talking about. So today, I'll talk to HPE Cloud Volume, and you might have heard certainly about Cloud Volumes. Not sure if you really practice with it, and I did work a little bit in order to create demonstrations which are available on the HPE demo portal as well. So if you want to see Cloud Volume in action, you can also go to the demo portal. You have, I think, some recorded demos, several recorded demos, and also some simulator as well. So you can really practice with it. It's fairly interesting. In short, for those who are absolutely not aware of Cloud Volume, it's a service which allows data migration from on-prem nimble environment to your cloud provider with a middle service, which is HPE Cloud Volume. So Cloud Volume is really a service stored somewhere, and we will see where, of data with replication between your nimble on-prem, between the Cloud Volumes and your cloud provider. So it's really about cloud mobility. And there is, let's say, two offers around the Cloud Volume. In order of appearance, the Cloud Volume block, which is really replicating the data you have from on a volume. And there is a new one, which is here for maybe a year or so, I'm not sure, which is the Cloud Volume Backup. Then you can back up your data directly into the cloud. So today we will focus on the Cloud Volume block, let's say the historical part. And what we will do is really see how we can manage Cloud Volume in an automated way using API. Before we go into that, some word about the architecture of Cloud Volume. It's, let's say, a three-pillar, normally kind of architecture. You have basically some data on-prem in your data center, which are stored into a nimble array, right? And during this demo, what we have. You can define a replication partnership with HPE Cloud Volume, and basically the real process is you get logged in Cloud Volume and you create the replication partnership. So it is initiated from the Cloud Volume interface, which is online once you have an account. And from here, you can create all the steps like a replication store, which is the place, the collection where you receive your volume collections, and so forth and so on. But I will go more into the detail from here. And then once you have your Cloud Volume replicated, so the replication goes via SSH connection. Once you have your data into Cloud Volume, you can present them to your cloud provider. In our case, we work with AWS, right? But it can be Azure or it can be Google Cloud, right? The three of them are available and supported. There are some reasons why we do work with AWS. One of the major one is because when you present a volume to AWS environment, you've got it for free, while when you use the equivalent of AWS Direct Connect with Google and Azure, you have some fee applied. So for demo purpose, obviously my manager told me, yeah, pick up the free version, and that's why I use AWS. But I mean, it's also the leader on the market, so it makes sense. Some more detail about how it works or the architecture. Once you are in Cloud Volume and you replicated your data, it's located in Equinix data center. So the demo environment I'm using is located on the East Coast in the US. And the nimble array where my data are coming from is located here in the office in Geneva, in the data center. So we do replicate from Geneva to the Equinix data center demo environment, again, in the East Coast. But if you use the production version, the one we do sell, you have the choice of the location, and I think it's in the UK, in the US, so several locations are available. So once you have the volume in Cloud Volume, you can present it to your EC2 instance, for instance, if it's AWS. And for that, you need to enable the service which is AWS Direct Connect. The setup of the AWS Direct Connect and the AWS VPC and all the thing in order to get Cloud Volume up and running with AWS is quite challenging. It's a lot of steps. If you need some documentation, there is a cookbook available. There is also, again, into the demo portal, a video which goes very much into the detail. So you have really a step-by-step documentation. So if you find it challenging and not enough detailed into the documentation, you can go on demo portal and really follow what I did in this area. So this is what we will use during this lab. Some terminology, I guess, if you are here, you are already aware of all the API, REST, endpoint, verb, header, JSON. I guess you are familiar with that. Here in the slide, it's documented. I'll just make a quick summary, but it's very short. So when we build an API query, the first thing is we need a query tools. So it might be just curl, the CURL tools, or Postman. So Postman is very nice for developing your query, and then you can translate them into any tools like Jupyter, as we do during this lab, or in a Bash or whatsoever. Associated with the query tools, you have a set of verbs. So the most default one is get, and then you have post, patch, delete, and we will use all of them during the lab. You have the endpoint, which is receiving the query, right? And here you have two endpoints, the demo Cloud Volume, which is the environment I'm using here, because again, it's the demo lab. But for production, you would use the same order with cloudvolumes.hpe.com API v2, right? The resources is the object you are querying, right? It might be a replication store, replica volumes, and so forth and so on. So we will see that in detail. And then you can, let's say, somehow sort the data you will receive as a feedback. And finally, you have the body when you can put some detailed parameter when you send a request, mostly for patch or whatsoever, right? Okay. So with that, I leave the slide and switch to Yes, here to the Jupyter Notebook. So this lab is not yet available for everyone. So today it's just a demo-led version, but we expect in a week or so to be able to put it online. So if you want to replay and practice on your own, you will be able to do it. There are 4 notebooks associated with this lab. The first one is really the introduction, and it takes back again, or it repeats what I've just said with the slide. You have also a view on or a summary of the Cloud Volume console, right? And we will make a quick tour just after. And I also added some blog post about API. If you are not really familiar with that, Didier and the team already published some notes regarding API, and you can review them and then get familiar with that. But normally it's okay. And yeah, we go to the end. And the next step is really to start the lab by itself. But before we start, we go to the lab. I would like to give you a short overview of the Cloud Volume interface. So again, what we will do during the lab with API is exactly what we can do during the GUI, right? The problem with the GUI, you know that, is you need to be in front of the interface and click and fill the data. While with the API, you can automate and operate using whatever the tools you want for automation in your data center, and get things done automatically. So various entries are into the Cloud Volume, and we have connection and cloud account. I cannot really show them because this is a definition of my AWS connection, and there is some, let's say, confidential data here. And then we have the replication partners. So the replication partners is really the path for replication from one Nimble and Cloud Volume. So as you can see here, I have 3 partnerships. So it means that I have 3 data flow coming from the same or various Nimbles located somewhere. So I have 2 in Geneva and 1 in the US, which are replicating data. Then we have the replication store, which tells, okay, what kind of volume of data, the kind of performance you expect, the location. So here, as I said, you have a single one, and we can go into, so I think it is this one we will use, and you can go into a specific replication store where you will get some more detail, like the volume collection, which can replicated into the Cloud Volume. You have an interesting data here. So the partner name is the name of your Nimble, the source Nimble, right? The number of volume you are replicating, and you have an interesting data, which is a direction, so incoming or outgoing. So it means that for this volume, for instance, the replication goes from the on-prem data center, on-prem Nimbles to Cloud Volume. And if it's outgoing, it means it leaves Cloud Volume and it goes somewhere, and the goes somewhere is the Nimble we have. So you can replicate in both directions, but not for the same volume at the same time, obviously, right? And we have replica volumes, which are the volume replicated. And it's also defined during the preparation. And here we have several of them. So let's look at this one, which is the one we will use during the lab. And you have information, the used capacity. At this point, this volume is used 0.5 gigabyte of data, so it's not that much. It's only text data I'm putting in the volume. And then I have snapshots, which are taken every day. So in the morning, I do take a snapshot and replicate the snapshot to the Cloud Volume. And finally, I can transform this replica into a block volume. And the block volume is the object I will present to a VM or to the EC2 instance or the Google instance if you have Google, right? So this is the kind of thing you have to do, and to reach this step, it's a kind of manual step you have to do, even though you can automate somehow the replication. So this is for the Cloud Volume, and let's go back to our notebook and start with the lab. So in the interface, yeah, I guess you are familiar with Notebook, but basically we have a mix of comment field and code areas, right? So every time I want to run a code, I just have to select it and execute it by clicking on this arrow, and it will work for some time, and then it will give me a feedback. Once the execution is completed, I will get a number associated to this box saying, okay, this is the sequence number X, you have executed, and it's completed by now. So the first thing I need to do in the process before I can do anything with Cloud Volume is I need to be certified for entering into the Cloud Volume. And for that, I need to collect a token. So normally the token is, you will get the token by running this command here. So as you can see, it's a curl post command. You have your endpoint, and so it's a post verb. The endpoint is HPE demo Cloud Volume, login, and you provide your email and password, right? At this point, obviously, for confidentiality reason, I don't want to get my email and password in a clear mode. So I created a short binary file where I do have embedded and hidden the credential, and I will send the order or will get the token using this execution file, right? It's just for question of confidentiality. So at this point, we should have get a token. So let's see if we indeed have it. And indeed, we have this sequence of characters, which is the parameter we need to send with each and every API queries for authorization, right? So we need to send that, and then we will be authorized because we have this temporary token. So I think it's valid for a couple of hours or so. So if you wait one day, for instance, you will need to get a new token again. So that's why I do store the token into a variable, then we can reuse it easily. So the first thing we want to do is to check if the token works by just querying. So it's a get again. So during the first part of the lab, yeah, just make a comment here. During the first part of the lab with this first sequence, we only collect data. We only run get, right? The other orders will come in the second step. So we will get information about our session. So let's run this query. So as you can see, curl again, get our session. We send as a parameter our token for the authorization, and we just say that the format of the data we are collecting is JSON. And we do receive these one-line strings, which is, yep, we have to admit, not that easy to read, right? Where are the information I want to have and all the things? So it's really almost impossible to read. So normally, what you need to become familiar with if you want to work with API is a small tools called GQ. So GQ, I think stands for JSON query, help you to format in a human readable mode the output or the JSON output you will get out of a query. It's pretty easy to handle. It requires some practicing, but after some try, it's easy to try. You will become familiar, and it helps familiarizing with these tools. In the notebook here, I added a link to some example, very easy example. And if you want to become familiar with that or make some experience, it's a pretty interesting page we can rely on. So let's use GQ for the exactly same query we run before. So we just pipe the output of the curl command into GQ. So let's run it. And here we are. So as you can see, we have a much longer list of information. This is exactly the same output of the previous query, but it's just transformed in a way we can read. So I'll obviously not read everything, but maybe just point some information. For instance, one of the information with my account is AWS configured. Yes. Azure configured. No. Some tabs or some information for connection are here. The ID and the account is my account here. And you get some information, first name, last name, information about the bandwidth, phone number. So obviously it's a fake one. I'm not an easy man. I do not provide my phone number at the first meeting, right? So I do provide a fake one. And some other information. Geo is the US, obviously, because we have seen it and so forth and so on. So at this point, we are able to get connected to the demo Cloud Volume with our API. We have a token, and we have checked that the token is working, right? So we validated the connection. Next step is get the list of the replication stores. So where let's say this is the space, the logical unit where we do store replication of the data. So say again, we have a get order. The endpoint is still demo Cloud Volume, and we query the replication store with the same parameters. So pretty easy. So let's run it. And here again, we can find a pretty long list of information. Not very easy to read, but at least we have the list of replication stores which are currently existing And I think we have seen we have 3 of them. Let's replication store, it's here. We have 5 replication stores. So we have test store, test cloud vol 01, vnimble 52. And if we drill down, we have HPE Cloud Volume 01. We have vnimble 52, for instance, which are the replication store, which are associated with IDs and a lot of information. So, no, sorry, the ID for the replication store is this format. It's 3-digit, 4-digit, right? And other information specifically to the replication stores. So what we would like to do, for instance, is instead of having this long list of information with a lot of things we don't need at this point, is just focus on the IDs of the replication store. So the query, the curl query is exactly the same, but at the end, we just use GQ with some filters, meaning that we remove the entries, we remove some brackets, and then we've got the ID. So we will just get the output for the ID field like here. So let's run this query. It works again. And here, so it's maybe not really easy to read, but we will get the ID associated with the 5 replication stores we have seen from the interface and which were listed in the first one. So we are able now to really filter and focus on some IDs. Today we will just focus, we will work with one of the replication store. So I put it as a variable here, and yeah, then I have this variable. And the nice thing we can introduce in the next step is when we create another query, we can also use a variable in the endpoint or in the query, because we want to focus on a specific replication store. So instead of hard typing 343 as focus object we want to go to, we just replace with a variable, which is here, rep stores, we have validated here. So let's run this API query, curl query, and then we will get detailed information about vnimble 52 FT. This is a strange name, but it's associated with another demo I'm supporting with the same environment. And we do have here some information for these replication stores. For instance, the proxy external ID, the replication IP. This is more internal things. The name of the nimble where the data are coming from, and several other things, IDs and all the things, right? So it means that just by adding the ID of the replication store, we can focus and get more detailed information, even more than what we would have got using the graphical interface. So here I just switched to the cloud volume, focusing on vnimble 52 FT, and this is the data we would have using the GUI. This is the data, the same data we've got using the API query, right? So now, next step, we have seen this replication. We want to see the replication volumes also. Which are the volumes replicated into Cloud Volume? So what kind of data and what kind of volumes? So here also we have several of them, and this is what you do see: replica volume, 2 volume, ftVol04, and a test, pretty long to read. And we've got them here, test volume here. And the second one is ftVol04, right? And again, we find information about the volume replicated into this stored. Again, the object we need to get in order to work on a specific object is the ID. So here I do use GQ again to collect the ID of the replica volumes existing in my environment. So let's run the query, filter the output. The dash R in GQ, remove the quote. Then you have a pure text command. So this is interesting to know when you transform that into a bash for automation. By default, GQ return a field with quote at the beginning and at the end. And sometimes it's not very good if you just use a string format in your code. Use dash R to have just the string by itself. So what we can see is we have two IDs, the two IDs of the volumes we have seen previously. So we will focus on one of them here, check, and define again another variable. Then into the next query, we will focus on one volume here out of one replication store. So still a get where we do want to collect data from this specific volume coming from this specific replication store. So really, we are really digging into the data of the Cloud Volume objects. So let's executing it. And we find some more information on ftVol04. If we go to the Cloud Volume interface, this is mostly the same as clicking on this object, volume name, ftVol04, the size, the used capacity, the encryption status, and so forth, and the list of snapshots. So at this point, we do see that it's located here, the name of the object and the collection incoming direction. So it means that the data are coming from an nimble to the Cloud Volume, and so forth and so on. Used size, it's defined here. Size object is defined here, 9 GB. And yeah, this is what we have. What we have seen as well is, let me go back to the interface. We have a list of snapshots. So for this specific volume, we keep snapshot of the volume, and you can see it's coming almost every day at the same time. So I'm cloning it. I'm cloning the snapshot every day at 2 a.m. in the morning, or 2 a.m. and a half. And I keep online like 10 snapshots. So if we want to store the volume, the snapshots existing, we just have to add snapshot to the volumes, and we will get the detail. And what I did, I added to my query some execution parameters. And what I want here is the output of my get command to be stored on the creation time. So let's execute it. And again, the execution will, I mean, the output is pretty long because we have like 10 or 11. I'm not sure how much I keep object. But what we want to look at here is, where is it? Let me find it. Yeah, it's here. Creation time. So the output, the output is done using this creation time field. So it's a time, again, not very easy to read. Obviously, if you go to the interface, you have a real date with format we are familiar with. But here it's a timestamp, and this number, which is the number of seconds, is the oldest one. So let's let's open a notepad. Let's pick up this one. And if we look for the next timestamp, this one, okay, we can see that the second one is slightly higher. So this one is the oldest one, and then we is here. And if we go to the third one, we will see that it really increased. So it means that we really have a sorting of the snapshot done using the creation date, right? So it means, don't save, the last one which is here. TAC is the latest one. It's the one created this morning, right? So what we will do, as we will focus on a single object, we will just run this query and collect the snapshot ID from the last object. So here where I do create a list and I pick up the last one. It's not very optimal in terms of code, but I mean, we don't really care. The important point is we have this snapshot reference because we will work with this snapshot reference to create a block volume. Here, we can also have a look to the existing block volumes. And it's a very long list. So I didn't use the GQ here because otherwise it would take a while before we've got the output, and it will be extremely long. So it's not very important, but just for your information, we can get the list of cloud volumes. And here there is an interesting thing. If you work with cloud volumes, if you go to the block volumes, so cloud volumes and block volume are the same thing. Currently, we have a single block volume existing. While here, you need to trust me, but I can tell you there is much more than one. So why do we have one cloud volumes or block volume existing in the GUI while there is much more existing using the API? Reason is because when you delete a cloud volume, it's not physically deleted, it is just logically deleted. So if I filter again the existing cloud volume, but my filter is mark for deletion equal to 0, meaning that I only filter on active cloud volume, I'll get a single cloud volume, right? And the volume we have existing and active at this point in time is called Cloud Vol Test 2021-0106, so the date plus a timestamp. If we go to the interface, we have a block volume called Cloud Vol Test 2021-0106 plus a timestamp. So we are aligned between our API query and the cloud volume. Okay, so with that, I just have to back up my environment for the next part of the lab, and then we can move to the next part. Before we start with the second part, which is more manipulating, creating objects, do we have any question I should handle, or is it okay?
I didn't see any questions that, yeah, somebody suggested, Christopher suggested that you use -- silent in your curl query so you don't see the progress bar.
Okay.
That's a good feedback.
Good
no, otherwise, there is no question that I've seen. So yeah, you can go on.
Okay. Okay, so let's continue then. And as I said, the second part is about manipulating object in Cloud Volume. So we will introduce some new orders. So the first thing, I need to load my environment variable because I changed the notebook, so I need to reload them. And then we will just check that everything is okay. Up, running the connection. So our token is still valid because I can get connected and then check that I'm connected, right? Fair enough. So now what we will do is we will create a new cloud volume, right? So the first thing is we will create a name for the cloud volume. So this name need to be unique. And the name we are creating will be this one. So it's associated with the timestamps, and in the case of where several people are running this lab at the same time, we are almost sure that the cloud volume will be different because we have this timestamp associated plus the process ID in the name. So we are pretty sure we are allowed. So here we will introduce a new verb, which is post. So it means that we will create an object to the destination. And here, what we want to post is really to create to clone a volume. So we were able to list the replication volume we had, and the order we will say is create a new object, clone it. And here it becomes interesting because we have some parameters. So we need to say the new volume you are creating, it will get this name, new cloud volume name, the one we defined here, right? Just above. And it will be associated with this environment, with this VPC private cloud. So the object will be eligible to be mounted into our AWS environment because we have this VPC network created in AWS. This was done when I set up AWS connection to Cloud Volume. So it was done previously. We haven't seen it. And the subnet we are using is a 10.0.0.16, the network which we have defined in AWS. So what we do say is create this volume and make it eligible for this AWS network, right? So let's create the clone. So it's working. It will probably take a bit of time. And then we have a new ID, so a new object ID, which is 8226. So we have a new cloud volume, and we can just querying it. Let's check. And it's here, right? We have a cloud volume test 1001 plus the timestamp. If we switch to cloud volume, and if we refresh the list of block volume, it appears. It's here. So now we have two volumes which are offered to AWS Cloud. At this point, you can notice that we have these colors, a green here and a gray here, which are telling the status of the cloud volume. When it's green, it means that sorry, give me 1 minute. It is my daughter. Sorry. Sorry for the interruption. Home office activities. So we have two objects. One is green because it means it's active, it's mounted somewhere, and one is gray, meaning it's free, it's not presented to anywhere. So obviously you can echo cloud volume name. I think it's just for checking purpose. Yes, it's here. So the next step is we want to attach this volume. So the volume which is here, if I click here, we can see that it's not attached to any volume, right? So we will, using the command line, attach it. So the first thing we want to collect is the initiator IP, which is the IP address, the internal IP address of the VM where we will link the volume. And at this point, I need to switch to my AWS console management. So I'm here, I'm in Amazon Web Service. I have some EC2 instance running, at least created. So normally I should have 2 instances running, right? It's here. Let's remove that. And if I do click on this specific VM, I will find that the private IP for this VM is 10.0.0.171. So this is a target where I will do mount this new volume I created. So as you can see, I picked up this initiator IP. It's needed for attaching a volume. So I picked up the initiators and I selected this one. So from here, I will be able to post, so send an action to Cloud Volumes. And I will, this Cloud Volume ID, I will attach it to this specific IP. So let's run it. And normally it should be be assigned. So let's check with the next query. Up. And we have an IP here. And if we look for assigned initiator, where is it? Assigned initiator. Yeah, this is these areas. Assigned initiator, it means the volume is assigned somewhere. So let's check the status in the cloud volume. If we refresh our informations, we can see that it is indeed attached to AWS to this host IP. So at this point, it's attached, but it's not connected. There is an extra point. It's a bit of challenge to get everything up and running, I have to admit. And the next step is really to make the connection. It can be done automatically. With Windows, it works pretty fine. Here, in my case, I have some troubles, so I need to do some manual step for getting the connection, or I automate specific tools. So for doing that, I need to set up two variables, and then we will do that. So the first one is this one, and I'll show you how I do that. So I have here it's CVCTL. So there is a tools we can use, which is this one. So talk. So okay, it looks it is the same, and the cloud volume. I will replace it as well. Cloud volume is this one. Ah, alors, voilà. Here we are. So what I'm doing here, I just executing a tools which is called CVCTL. So it's Cloud Volume Control, provided by HPE. And using this tool, you can connect, list, and check the volume you have into the system. So first thing is, let me Control R, CVCTL list, Cloud Volumes. So at this point, we have only one volume presented to our VM. If they have -h, actually this is this one, right? So it's already here. I mounted it on /CV. But what we want to do now is to present a second one. So we will just run this CVCTL command. It takes some time to execute, but normally it tells us that it's a success. So hopefully, if we list again the cloud volume, we have a second volume presented to our VM. And if we run a fdisk or something, we will see that there is another external volume presented to the VM. We will check the status into here. So at this point, the connected status remain as false. Be aware that normally it takes like a minute before being refreshed. So it might remain as, no, it's okay, it's done. So now our volume is attached and connected using this initiator name because it's a nice cozy connection, right? So the cloud volume is now mounted and presented into EC2 instance. As I use LVM, if I really want to mount it, I need to work LVM to manage to activate and recognize the object. So I cannot do it right now, but it's the way it works. At least the volume is ready, is presented. You just have to work with it and to work on the data you have into it, right? So what we can do is just delete, no, no, sorry. Let me leave that. So I need to find again, disconnect, yeah. So what I want to do now is to just disconnect the volume. So the target ID is this this one. And it's disconnected. If we list, so the volume is not available anymore, right? But you can easily script that, and it's what I did in one of the examples. So let's check. So it's still connected at this point because it takes like a minute before it disconnected. No, still. So let's wait a moment. We will check that just after. And when it's disconnected, we can finally detach the volume. So it's not related to a provider anymore. So we can run this post order, detach again. As an body, we can provide the initiator IP, so the volume, and now it's okay. So let's see the status. Yep. Here it is. So there is now no cloud VM attached to this volume. So the volume is free, right? Let's go back to block volume. And we can see that the color is back to gray because it's not associated with a VM. And finally, what we can do is just delete this volume we have created. So let's execute it. A delete verb we will use for the API. And as a parameters, we do say cloud volume ID, so the object we have created. Let's delete it. And at this point, it should be done. Let's see if we can read it again. So this specific cloud volume. And yes, we can read it. But if we look at the line marked for deletion, it means that this volume is not active anymore, right? It's only stored for historical purpose. And if we check the status of our block volumes, it disappeared, right? So we programmatically manage the creation, the presentation, and the deletion of the volume.
Jan?
Yep.
There is one question in the chat. Obviously, maybe you won't be able to answer it right now, but one person is asking whether a similar content will be provided for handling backup and describing how REST API could actually list backups and restore volumes actions.
So it does exist, maybe not in this format. So maybe one thing let me show you. One thing you can do is obviously look at the reference documentation. So Cloud Volumes, you have the REST API things. There is a Cloud Volume reference, and there is the entry for Cloud Volume backup as well, with a list of orders. So I didn't test them myself, but it does exist. And there is also on GitHub under HPE, there is a list of Postman queries already done. So you can download that. It includes Cloud Volume, Postman queries, as well as Cloud Volume backup, or backup volume with Postman queries. So you already have some template you can use for querying. So I guess it's a very good starting point. You start with that, and you will already have a list of example API queries for backup volume as well. Well, and with that, I think I'm almost done. So I wanted to share, before I close, I wanted to share the Cloud Volume reference. If you are interested by a bash file embedding all this query, I also have a GitHub. So I publish mine on GitHub. So if you go to HPE Cloud Volume API example, you have already some shell script having all the order in a single file, collecting the information. So if you want to automate the thing, it's here. I do use it for more than 2 months on my side, and every day it refreshes the content of a volume. It's exactly what you have seen here. So if I go to so let me clear first. cd/cv/ft. So I do have a volume. I do update with aircraft activity around Geneva every day. And every day I do add a file and it's replicated, right? So, and it works for the last 2 months. So, so at least you have a good starting point. If you go to the GitHub page and you want to automate something, it's already here created in a bash mode, right? And with that, I think I'm done with the presentation.